Hello students, this video is the first lesson in the third unit. We're going to be talking about transversals and angles. There are a lot of vocabulary words in this lesson, so get ready for that. We're going to be talking about all the angles that are formed when two parallel lines are intersected by one line that intersects them. That's called a transversal. In the learning target, let's understand what we're supposed to be doing here. We're applying transversal relationships. So all the relationships that we talked about with triangles, triangle relationships, these ones are called transversal relationships. They have different names. And we're going to be finding angle measures on a diagram. So specifically what the measure of angle this is, what the measure of angle this is, etc. And we're going to be justifying our responses by using those relationships. I think that this angle is this because of this reason. Take a look at the do now. It asks you to identify all pairs of supplementary angles. You should remember those from last unit, and all pairs of vertical angles. You should also remember them from last unit. For example, if I wanted to take a look at this diagram, I can find that there are supplementary angles here, like angle A and angle B are supplementary because they form that straight line. And also vertical angles I could identify by saying, well, angle E is vertical to angle H. So identify all of those pairs. Pause the video and try this one out. Okay, you should see that there are a lot of different pairs of supplementary angles. All of the different pairs that make up a straight line can be counted as supplementary angles, like E and G, for example, or G and H. Any two adjacent angles that form a straight line are going to be considered supplementary. There are fewer pairs of vertical angles because we just got to go across each of these intersections, A and D, B and C, etc. So 4 pairs of vertical angles, 8 pairs of supplementary angles. That leads us to a couple of definitions. When I look at these two lines, I can identify that these two lines are parallel. I know that they're parallel because of one specific part in them, and that is what I've just highlighted here in purple. These two arrows indicate that the lines are parallel. They indicate they run alongside each other, they never intersect, and they have equal slopes. This part that I highlighted in green, these two parts, are called intersections. So when this line segment, EF, which is called a transversal, intersects two parallel lines, like line segment AB and line segment CD, they form two intersections, all right? So now that you've gotten a little bit of a baseline of vocabulary, let's take a look at the first definition. A transversal is a line that intersects two parallel lines. And you can see here in the diagram, I've drawn two parallel lines, and this line is a transversal because it intersects both of those parallel lines, forming two intersections. For this next definition, we call corresponding angles in two different intersections that are in the same position, and these angles are congruent. Here's the diagram. All right, you should be able to see in this diagram that this angle down here for this intersection is on the bottom left part of that intersection, so it's in that position. And in this intersection down here, we call it intersection when the parallel line touches the transversal, this is also in the bottom left portion of that intersection. So they're at the same position, same relative position. So bottom left, bottom left. And it turns out if that they are in the same relative position, they're congruent, which, as you know, means equal measures. And you'll see later, it makes sense, right? You can see that these two angles are sort of larger than the other angles, like these smaller angles. We're going to talk about how to identify all of these angles, specifically whether they're congruent or not, a little bit later. For alternate exterior angles, it is the following definition. They are angles on opposite sides of the transversal, either the left and then the right side, outside the parallel lines. And these angles are congruent as well. As you know, that means equal measures. So in the example, here's an angle that is on the left side of the transversal, this line that intersects both lines. And here's an angle on the right side of the transversal. This one's on the right, this one's on the left. And they're also outside the parallel lines. We call in here the interior of the parallel lines. They're outside the parallel lines, not between the parallel lines. And it tells us that those angles are congruent. They will always be equal measures to each other. Though these are not the only examples of alternate interior angles. You could say that this angle up here and this angle down here are also alternate exterior angles because they follow the rule. They're opposite sides of the transversal and outside the parallel lines. Moving on to alternate interior angles. So you could probably guess that alternate has that same definition of alternate up here, but interior means something different than exterior. Once again, we're looking at angles that are on opposite sides of the transversal because that alternate means opposite sides of the transversal. Same thing up here, alternate means angles on opposite sides. And in this case, it's interior, so they're between the parallel lines. This angle is on the left-hand side of the transversal. This angle is on the right-hand side. This angle is inside the two parallel lines because it's between those two parallel lines, and same thing here, it's between those two parallel lines. It tells us that the angles are congruent, which means that this angle is congruent to this angle. They're the same measure. All right, moving forward to consecutive interior angles. This doesn't say alternate, so we're not going to be talking about opposite sides of the transversal. You could probably guess that we're talking now about the same side of that transversal. Here's the definition. All right, here's consecutive interior angles. They're on the same side of the transversal between the parallel lines. So I have this angle that is on the left-hand side of the transversal, and this angle which is also on the left-hand side of the transversal. They're also between the parallel lines, right? This angle is inside the two parallel lines, and so is this one. And it turns out that these angles are not the same measure. They're not congruent. They're actually supplementary, which means this angle plus this angle is going to be equal to 180. So notice I'm using 2 dots and 1 dot because they are not the same size. They're different sizes. However, they do add up to 180. And the last definition we want to talk about here is consecutive exterior angles. You should have compiled a little bit of an idea of what the consecutive means by now and what the exterior means by now because we had them in previous definitions. I will give you the definition now. All right, consecutive means same side of the transversal. Exterior means outside the parallel lines. In this case, you can see this angle is outside the two parallel lines and it's on the right-hand side of the transversal. This is outside the two parallel lines, still on the right-hand side of the transversal. And these angles are supplementary, which means that this angle plus this angle will have to give you 180 degrees. Why am I telling you all these definitions? Because all of these definitions are reasons for you to set up a new equation or a new relationship between two angles and to try to solve for those angles. Let's talk about what that looks like. In this check for understanding, all you have to do is identify one pair of corresponding, one pair of alternate exterior, etc. I'm going to give you all the pairs, but all you have to do is identify one of them. So pause the video, try these ones out, and I will show you the correct answers in a moment. All right, you had a lot of different options for this first one, corresponding angles. When I look at angle 1 and angle 5, they are both in this particular position in that intersection. They're on the left-hand side of the top, left-hand side of the top, right? You could have identified 2 and 6, 3 and 7, and 4 and 8, respectively. They're just in the same place, but a different shape. In a pair of alternate exterior angles, you could have identified alternate exterior being like angle 1 and angle 8. In other words, those are on opposite sides of that transversal. Remember, the transversal is this one right here. It's intersecting both of those parallel lines, and they are outside the two parallel lines. For alternate interior, the alternate interior angles would be the ones that are like, for example, angle 5 and angle 4, right? They're on opposite sides of the transversal, and they're between the two parallel lines. And last but not least, consecutive interior angles, we could have identified that angle 3 and angle 5 are consecutive interior angles because consecutive means they're on the same side of the transversal and interior means they're between those two parallel lines. Now, I want you to notice I used angle 5 in a lot of my examples. I used angle 1 in a lot of my examples, which means that angle 1 has a relationship to angle 8 that is alternate exterior, but it has a different relationship, angle 1 does, with angle 5. You can identify multiple different relationships for each of these angles. So you know it just depends on which pair of angles you're talking about to identify that relationship. All right, how does this look in an actual problem? Well, let's see. In the diagram, it tells us that lines N and M are cut by transversals P and Q. So both P and Q are these transversals. They intersect both parallel lines. Which value of X would make lines M and N parallel? So it doesn't say that they're parallel, but it says which value of X would make them parallel. So let's take a look at the diagram. We have 80 degrees here, we have 30 degrees here, and we're able to find out some of these angles, but let's look specifically at angle X, which is here. Angle X is an angle that is not given to us. However, I know that this angle has a relationship with this angle, for example. This angle and this angle are called alternate interior angles. They're alternate interior because they are on opposite sides of the transversal, and they're between the two parallel lines. So if I knew this angle and this angle, I would be able to say, well, if these are the same, alternate interior means that these two lines are parallel. But unfortunately, I don't know this angle, so that's not super helpful to me. Well, let's fall back on the old standby. I know that this angle is 80 and this angle is 30. Those two angles form a straight line, this straight line here, with a third angle, which is missing to us. This is an angle that I don't know, so let's use supplementary angles first to try to find that missing angle and see what we can use that for. And this should be old news to you guys. You know how to use supplementary angles to find a missing angle by setting all the angles that make up a straight line equal to 180. We get the angles equal to 70, so this angle is 70. All right, now we have a little bit more information, and now we can make our decision. I know that in this situation, I'm looking at angle 70, which is here, and angle X, which is here. Both of these two angles have a relationship between each other, this angle 70 and this angle X. It turns out that they are both on the same side of that, they're both in the same position for this intersection here and this intersection here, which means that these two angles, this angle X and 70, are corresponding angles. Or they would be if M and N are parallel. So in other words, it's asking what value of X would make lines M and N parallel. Well, if angle X was equal to 70, it would ensure that these two lines are parallel because of corresponding angle. So it looks like we've answered our question here. What value of X is the value that they're looking for? And it would be the measure of angle X is equal to 70. Oh, I don't need a degree symbol because I'm using M. All right, got rid of that. Perfect. So that was the first model problem. In the second model problem, it gives us a situation and it tells us that the measure of angle 1 is 4x plus 14 and angle 2 is 8x plus 10. Let's see what the relationship is between these two angles. All right, if they were corresponding, they'd be in the same relative position for the two different intersections. This one's at the bottom left, but this one is not. It's on the bottom right, so it's not corresponding. If they were alternate interior, they would both be between the parallel lines. This one is, but this one is not, so it's not alternate interior. If they were alternate exterior, then they'd be on different sides of the transversal, but outside the parallel lines. This one is inside the parallel line, so that's no good. If they were consecutive interior, they'd both be inside the parallel lines and on the same side of the transversal. Well, they are on different sides of the transversal, and one of them's inside and one of them's outside, so I can't use that. And then consecutive exterior, they would have to be on the same side of the transversal, and they would have to be outside of the parallel lines, but they are not that either. All right, we've come to a situation where we can't use any of the following. However, we can use another method, which I like to call the big and small method. I refer you back to the beginning of the video where I showed you the title placard. It does say that in any relationship in which you have two parallel lines with a transversal, you can split all of the angles into so-called smalls and bigs, small angles and big angles. So what I'm going to do for this problem that we're faced with here, the model problem, is identify all of these angles as small angles and big angles. All right, we've identified all of the angles as either small or big. In this case, I can tell that angle 1 is a small angle and angle 2 is a big angle. Now, I should tell you that when I'm dealing with a transversal and two parallel lines like this, it turns out that all of the big angles are going to be congruent to each other. And all of the small angles are also going to be congruent to each other. And it also turns out that the small and big angles have a relationship between each other as well. Let me summarize those relationships down here. To summarize, all the big angles are equal to the big angles, all the small angles are equal to the small angles, and a big angle plus a small angle is going to be equal to 180. This might seem a little simplistic, but it always works with parallel lines and transversals. So this is a good thing to keep in mind. If they're the same, they're equal. If they're not the same, they add up to 180. So how does this help us with our problem? Let's set up an equation with one small and one big. All right, we're using transversal angles rule to say that big plus small is equal to 180. 8x plus 10 is the big angle, 4x plus 14 is the small angle, and they should be equal to 180. Now it's just algebra. All right, seems fairly straightforward with this algebra here. All we have to do is combine like terms, move the numbers to one side, and then solve for x. X is equal to 13. And the question asks us, what is the value of x? So we are done. Keep this, this big and small method in your back pocket because it will definitely be helpful when you're doing questions like these. All right, this was a video on transversals and angles. Good luck studying.